On October 19, 2017, Pan-STARRS detected Oumuamua after it had already passed closest to the Sun, and was racing back out of the solar system. That is the first evidence payoff. Humanity discovered its first confirmed interstellar visitor almost too late. It was not orbiting the Sun. It was not from the asteroid belt. Its path was hyperbolic, meaning it was unbound and came from outside our solar system. Then the stranger got stranger. It showed no obvious comet tail, its brightness varied wildly, and later analysis found a small push that gravity alone could not explain. That combination made Oumuamua famous: first visitor, weird shape, no coma, unexplained acceleration, and a public argument over whether natural physics was enough. Oumuamua entered the inner solar system on a path too fast and too open to belong here. It passed perihelion, its closest point to the Sun, on September 9, 2017. By the time Pan-STARRS found it in October, the object was already outbound. That short observing window matters. Astronomers had weeks, not years. The object faded quickly, moved fast, and became too faint for even powerful telescopes. So every conclusion comes from limited data, brightness changes, trajectory, color, non-detections, and models. This is not a mystery where we can go back and take a better look. The evidence is a trail left by something that is gone. Oumuamua was too small and distant to photograph as a resolved shape. The famous cigar image is not a direct picture. It is an inference from brightness. As the object tumbled, its light changed dramatically. That suggested an unusually elongated or flattened body, or at least a shape and rotation state unlike ordinary expectations. This is where the public imagination took over. A long, tumbling visitor from another star sounds like science fiction, because it is exactly the kind of thing science fiction trained us to notice. But the evidence is more careful. Confirmed, the light curve was extreme. Interpretive, the exact shape is model-dependent. At first, Oumuamua was classified as a comet, because interstellar icy bodies were expected. Then observers looked for a coma, the fuzzy cloud of gas and dust that active comets often show near the Sun. They did not see one. That forced a reclassification to asteroid-like, and later the new interstellar designation 1I. But the no-coma clue created a trap. No visible coma does not automatically mean no outgassing at all. It means ordinary dust-rich comet activity was not detected. The difference matters, because the later acceleration still needed an explanation. The biggest physics clue came from the trajectory. Gravity from the Sun and planets did not fully explain Oumuamua's motion. There was a small non-gravitational acceleration, directed roughly away from the Sun. For comets, that kind of push often comes from outgassing. Material heats, escapes, and acts like a tiny rocket. But Oumuamua had no obvious coma. That tension drove the debate. If outgassing caused the push, why did we not see the normal signs? If outgassing did not cause it, what did? This is the exact place where speculation entered. Some argued that solar radiation pressure could explain the acceleration if Oumuamua were extremely thin and light, like a sail. That opened the alien probe headline. But the claim is disputed. A light sail requires unusual geometry and assumptions. It also has to compete with natural explanations that do not require technology. A good Mystery Atlas episode should not pretend the idea was never discussed. It should label it properly. Confirmed, radiation pressure was considered as a possible force. Disputed, that the object was artificial. Interpretive, the simplest surviving explanations should be tested before reaching for alien engineering. In 2023, Jennifer Bergner and Daryl Seligman proposed a natural explanation that changed the discussion. Their model begins with water-rich ice traveling through interstellar space. Cosmic rays can process that ice and produce molecular hydrogen trapped inside it. When the object later warms near the Sun, hydrogen can escape from the ice and create a push without carrying much dust. That could explain the acceleration without a visible coma. This is elegant because it connects three clues at once: interstellar travel, no dust-rich comet tail, and a non-gravitational push. It does not mean every detail is settled forever, but it gives the natural side a much stronger mechanism. Oumuamua is gone, so uncertainty remains. We do not know the exact parent star. We do not know its exact shape. We do not know its full surface composition. We cannot send a telescope back to 2017 and collect better data. That is why strong claim labels matter. Confirmed, it was interstellar. Confirmed, it lacked a visible coma. Confirmed, it had non-gravitational acceleration. Interpretive, hydrogen outgassing is a strong natural model. Disputed, alien probe claims. The mystery is narrower now, but not erased. Oumuamua was not alone for long. In 2019, astronomers found 2I/Borisov, another interstellar object. Borisov behaved more like a recognizable comet, with obvious activity. That comparison made Oumuamua even more interesting. The first visitor looked weird and almost silent. The second looked more familiar. Together, they suggest our solar system is being crossed by debris from other planetary systems. Some will look comet-like. Some may look stranger. The sample size is still tiny, but the future is opening. The next major step is not arguing forever about one lost object. It is finding more. New survey telescopes, especially the Vera C. Rubin Observatory, are expected to discover many more fast-moving, faint objects. That matters because one object can be weird by accident. A population can reveal patterns. If future interstellar objects show similar acceleration, similar shapes, or similar quiet outgassing, Oumuamua will look less like an exception and more like the first member of a family. The real answer may come from statistics, not one perfect photograph. So what was Oumuamua? Confirmed, the first confirmed interstellar object detected passing through our solar system. Confirmed, discovered by Pan-STARRS on October 19, 2017. After perihelion. Confirmed, it showed extreme brightness variation, no visible coma, and non-gravitational acceleration. Interpretive, hydrogen outgassing from irradiated water ice is now one of the strongest natural explanations. Disputed, alien spacecraft or artificial sail claims. Unresolved, exact shape, origin, and surface chemistry. Oumuamua is still extraordinary. It just does not need to be artificial to be extraordinary. If another Oumuamua entered the solar system tomorrow, what would you test first? Its trajectory, its hydrogen outgassing, its surface color, its shape from the light curve, or its parent star. Tell me the evidence that would change your mind. And stay with Mystery Atlas for the next visitor from beyond the solar system. And non-gravitational acceleration. Interpretive, hydrogen outgassing from irradiated water ice is now one of the strongest natural explanations. Disputed, alien spacecraft or artificial sail claims. Unresolved, exact shape, origin, and surface chemistry. Oumuamua is still extraordinary. It just does not need to be artificial to be extraordinary. If another Oumuamua entered the solar system tomorrow, what would you test first? Its trajectory, its hydrogen outgassing, its surface color, its shape from the light curve, or its parent star. Tell me the evidence that would change your mind. And stay with Mystery Atlas for the next visitor from beyond the solar system.